These tools are high impact, cutting edge, and big, really big. Their challenge? Build hundreds of feet straight up, the indispensable tools of the high-rise, taking us from dirt lots to soaring towers. Super tools, skyscrapers, next on Modern Marvels.
Building a skyscraper is an extraordinary feat of human ingenuity, exposing millions of pounds of concrete and steel to the twin enemy forces of wind and gravity. From New York, from Chicago, and from Las Vegas, we're gonna get an unusual perspective on how a skyscraper gets built by going behind the scenes with the tools that make it possible. The tower crane, the impact wrench, the power trowel,
4 machines or 5 machines today.
the total station, and the foundation drill rig.
The construction industry builds at a very rapid pace now, and without these tools, you could never maintain the pace that is expected by ownership.
The first step in building any skyscraper, making the foundation. To do that, holes are dug and then filled with concrete. These shafts will support the enormous weight of the building.
The foundation is the key element. If it's not correct, the building will sink or the building will lean.
To prepare the support structure, a key tool is deployed: the foundation drill rig. And here in Chicago, the rig is being put to the test.
We are working on the Trump International Hotel and Tower. We are installing the deep foundations for the building. The building is going to rise to 92 stories.
That translates into a weight of 720 million pounds. But the soil in Chicago is made of clay, which can't support that kind of weight. So the building will have to rest on the layer of bedrock below the clay. And that means digging foundation shafts 170 feet deep. Today, the crew has to finish the last 30 feet of a hole they began 2 days ago. They're using a drill bit called an earth auger.
So we use this to drill down to the top of rock, actually. And as you can see underneath the auger, there's a row of earth teeth. They're flat teeth, and that's what digs the clay out. When the auger is full, then they hoist the whole auger out of the ground, and they spin the clay off.
They're going to extract over here.
But the earth auger is just one type of interchangeable drill bit they're using here. And those bits are just one of the components that make up the foundation drill rig. First, a 120-foot crane holds the whole apparatus in place. A diesel engine provides the turning power for what's known as a Kelly bar.
All the tools have heads that fit into the Kelly bar, and whether if it's an earth auger, if it's a rock auger, a core bucket, the Kelly bar holds all the tools in place and allows the excavations to happen. He's reversing the Kelly bar right now.
Digging each foundation shaft takes between 3 to 5 days.
He's got it.
And there are 57 needed for just this building. It's a pace and scale that was unthinkable at the beginning of the skyscraper era in the 1880s. Back then, workers dug foundations by hand with shovels and pickaxes. A process called hand mucking. It was very inefficient.
When they're doing hand mucking, it's a slow process, slow and tedious.
It took workers almost a year to dig the foundation shafts for one of New York's earliest skyscrapers, the 34-story tall municipal building begun in 1909. By 1913, skyscrapers like the Woolworth Building were reaching heights of over 50 stories. With buildings getting taller and heavier, foundations needed to go deeper. And manual digging was just not up to the task. So over the next decade, various mechanical digging devices began to be used on foundations. But a breakthrough came in Texas, where water well excavator Ed Duderstadt would find a new use for his drilling equipment.
In 1922, my grandfather was drilling water wells on a ranch in a part of the Bexar County that's now San Antonio. While he was working there, the owner was in the process of developing plans to build a new home. The engineer that was designing that home was Willard Simpson.
Simpson wanted to build a solid foundation for the house, but he was confronted by unstable soil in San Antonio.
Willard had been toying with the idea of doing drilled shaft foundations instead of what at that time would have been a hand-dug spread footings.
To drill the shafts, Duderstadt and Simpson teamed up and repurposed a water well digging rig. The machine was fairly primitive. In fact, it was powered by horses or mules.
The top part here was called the turntable, and it rotated. The operator rode on the turntable, and so he was going around in a circle the entire time.
As the turntable rotated, it turned the Kelly bar, twisting the auger deep into the earth.
When the auger is full of dirt, then the winch was used to pull the auger out of the hole, and the dirt was just deposited out here in front of it.
Compared to the roughly 2 feet an hour it would have taken to dig by hand, the drill rig was able to dig at a rate of 10 feet an hour.
And those were the first drilled piers done in San Antonio, and we believe possibly in the nation.
With this early success, the foundation drill rig industry was born. In the 1950s, new drill bits were introduced which were designed specifically for local soil conditions. The bucket auger came from California because it could scoop out the soft, sandy soil. And the spiral auger developed in Texas because this type of auger could more easily slice through the harder clay soil in the Lone Star State. A decade later, super hard tungsten carbide began to be used on the drill bits. But the elusive goal of pulverizing bedrock would have to wait until the 1970s and the Trans-Alaskan Oil Pipeline. For that project, the percussion hammer was developed.
The percussion hammer would readily drill through the permafrost and be able to drill any rock formations that were encountered.
But the tool was soon found to be strong enough that it could plow through bedrock itself.
After the Alaska Pipeline project, they were carried on into the foundation business.
Beginning in the 1980s, the percussion hammer was improved by mounting multiple hammering heads onto one big drill bit, allowing for quicker drilling. And these tools remain a mainstay of the industry, including at the worksite in Chicago, where the percussion hammer is seeing action. When lowered into the hole, the individual hammers bounce up and down, crushing the bedrock. The pulverized rock is collected in a basket on top of the tool and dumped. After the hole is dug, this 7-foot wide, 105-foot-long piece of steel casing is inserted, which also makes use of carbide.
So on the 7-foot diameter casing, there's probably about 35 to 40 carbide teeth, and that allows the casing to be twisted right through the bedrock.
All that's left, filling up the hole with 85 cubic yards of cement. 49 foundation shafts down. Only 8 to go. But that's only the first step. It'll take many months and many more tools to build this skyscraper.
The biggest foundation drill rig in the world is called Big Stan. It can drill monster holes 30 feet in diameter, double the size of the average living room. Modern Marvels will return in a moment. We now return to Super Tools, Skyscrapers, on Modern Marvels.
After laying the foundation for the skyscraper, the next stage, building up. And that means lifting thousands of pounds of materials hundreds of feet into the air. And it's only possible with the tower crane. To see one in action, we're off to Las Vegas.
Okay, we gotta bring this bucket on up there and flip it over, right?
Affirmative. Be right there.
It's like the bat in baseball. Without the bat, you don't play the game.
All right, we got it.
The tower crane's like the center. You're not going to win a championship without top-notch center.
Got about Tommy Keith. Keep coming.
Tower crane's like Shaquille O'Neal. It's a little taller, maybe.
Without a tower crane, you wouldn't be building this building in 18 months. You'd be building it in about 4 years.
This new 30-story tall hotel tower for the Palms Casino is nearing completion. But the tower crane still has a lot of lifting to do. Steel, concrete, scaffolding, windows, and even other tools. Around the construction site, the tower crane sets the pace.
It's one of the few things where if it doesn't work, if it doesn't run, or the operator's not there, there's nothing that can be done on the job.
The vertical section of the tower crane is called the mast. The horizontal piece at the top has two parts. The longer one in front is the jib, and the shorter one at the back is the machine arm. Located in the jib is a track-mounted trolley that pulls the load in and out. Up to 1,800 feet of twisted steel cable, called a load line, does the lifting. It runs from a cable drum in the machine arm, through the trolley, and down to the ground. To hoist a load, the crane must lift, trolley, and rotate, all at the same time. During actual lifting, a key element of the crane comes into play: the counterweights. Huge slabs of concrete encased in metal that weigh 8,000 pounds each.
Tower crane is basically a big balancing act. When you pick up loads with the jib, you want your counterweights to pull the crane back into balance. It can pick up 22 tons out to 110 feet, but it can also take 8,000 pounds out to 230 feet.
It's essential that these careful calculations are followed. If not, there can be fatal consequences. In 1999, a supersized crane called Big Blue was being used to construct Miller Park, the new home field for the Milwaukee Brewers. During the building of the roof, the crane lifted a 450-ton metal piece.
What the hell is going on here?
But the load began to sway when the wind suddenly picked up.
Okay, watch it, watch it!
Three construction workers lost their lives in the tragedy.
There's always danger, but there's guidelines, OSHA regulations, federal standards. When the wind's above 42 mile an hour sustained, we have to shut the crane down. There's lightning within 3 to 5 miles, we have to shut the crane down.
No one knows the risks better than Eugene Clinton. He's one of the operators of the tower crane being used at the Palms Casino in Las Vegas.
It takes probably a good 15 years of apprenticeship and running cranes on the ground before they'll even let you in the seat of one of these tower cranes. So I'm 27 years into it now.
But before Eugene can put his skills to use each day, he's got to climb all the way up to the cab.
490-foot climb in the heat of August in Las Vegas in the desert. They'll take it out of a man. This is halfway.
Yeah.
It'll take me about 45 minutes in this heat to get up there to the top, so we'll take a nice slow climb.
Well, we made it. Now that the climb's over, we got an easy day.
Bob's gone home, you got Big Gene in the seat.
Big Gene's first job today, lifting this 20,000-pound bucket to the roof, 30 floors up.
Hello, Las Vegas. Away we go.
Each lift is called a pick.
Okay, we gotta bring this bucket on up there and flip it over, right?
All the picks done by the crane are pre-planned prior to them being done. It's not spur of the moment.
A signalman directs the crane's hook and then clamps it onto the bucket.
It's all yours, take it up.
Then Eugene engages the lift lever and the 10-ton bucket starts its 400-foot climb.
Nice and easy.
When the load has cleared the top of the building,
Swing it.
Eugene swivels the crane, bringing the bucket over the roof. Total time for this pick, 4 minutes. A monumental achievement that's the state of the art in lifting, but it wasn't always this fast. Although manual cranes had been in use since the Romans, it wasn't until 1839 that the first steam-powered crane began to change the construction business. The brainchild of inventor William Smith Otis, it was called the crane excavator. It had a large shovel attached to a system of winches and pulleys. But the steam-powered crane soon lost its shovel and gained a hook, making it possible to lift ever greater loads to ever greater heights.
There was a direct correlation between the development of cranes and derricks and the size of all types of construction projects that could be undertaken, especially skyscrapers.
But the jibs on the early cranes were raised and lowered from a pivot at ground level, limiting their reach around building sites. So the next step forward was to make cranes mobile, first putting them on rails, and then by the early decades of the 20th century, on treads or wheels.
Well, this is a 1926 link belt crane. It's pretty typical of the type of cranes that were built in the 1920s. The engine had to be hand cranked to start. If it doesn't start on 3 or 4 cranks, you're pretty well exhausted, and you have to get your relief in there to crank it some more.
But hand cranking wasn't this crane's only limitation.
Well, this crane weighs about 30 tons, and as a typical in those days, it could only lift about half its weight, where today's cranes would lift typically its own weight.
The tower crane, like the one being used in Vegas, wasn't introduced until 1949. Perfected by German engineer Hans Liebherr, these new cranes had a horizontal jib at the top, greatly enhancing their usefulness on construction sites.
What made it different is that this is a crane that could lift materials from the ground and hoist it and then swing over the new structure and place the material on the structure back in where it needed to be used. And that made a difference. Anything else had only been delivering materials to the edge of the structures and carried across the deck by manpower.
Liebherr's tower cranes were hugely successful, and by the 1950s, they dominated construction sites across Europe.
In Dusseldorf, I saw a crane that was reaching up over 300 feet in the air. And this was the time that before we ever had anything over 200 feet in ground-mounted cranes in the United States.
Ben was so impressed that he brought the first tower crane to the United States for his next construction project, the Sheridan Motor Inn in Binghamton, New York. But not everyone was as enthusiastic as he was.
The first crane that we brought over, well, it was a tough fight. And they said, "What are you talking about?" I said, "My daddy did it this way, and I'm going to continue to do it this way." And they didn't want to accept the fact that there was a different way that you could build a building.
But with its initial use in Binghamton, and then for the Pittsburgh Hilton Hotel in 1959, the tower crane had conquered America. And the clincher was locating the operator in a cab hundreds of feet up, because previously, operators had been near the ground and couldn't see very much.
We have always felt that's very important because the operator looking at what he's doing, both on the ground and where he's placing it on the deck, is certainly a great safety advantage, but it's certainly a productive advantage.
Tower cranes have gotten much taller and stronger over the decades. But the biggest improvement, electronics.
I've been working with tower cranes for 24 years now. When I started, there wasn't no electronics in the cranes. They've improved dramatically what the cranes can do.
To combat against disastrous accidents, tower cranes now have what's called load limiters. Computerized equipment that measures how much a load weighs, determines its distance from the mast, and calculates whether the crane can handle the pick.
These are my fault indicators. Let me know these lights light up. If there's a problem, there's a little siren here, an alarm goes off.
During today's shift, Eugene and his crane lifted a total of 21,000 pounds of material.
I built about a half a dozen of these high-rise buildings around here, including Mandalay Bay and Caesars and Bellagio, so it's fun to look back and see the work you've completed. It's a great job, and hey, living in Las Vegas, what can you say, buddy?
The largest tower crane in the world is the Kroll K-10,000. It can lift more than 260 tons and costs over $9 million. Modern Marvels will return in a moment. We now return to Super Tools, Skyscrapers, on Modern Marvels.
the next stage in building a skyscraper, connecting everything together. And for that, you need bolts. Lots of bolts. And the only way they're getting tightened is with the impact wrench. At the site of the new headquarters for the New York Times in Manhattan, the impact wrench is being put through its paces.
We're on the corner of 41st Street and 8th Avenue in Manhattan. We're standing on the 18th floor right now, and we're erecting the 19th and 20th floor. The building's eventually going to go to the 52 floors with a 350-foot mast on top of it.
The whole project will weigh about 150 million pounds, but just the structural steel will be about a third of that, 50 million pounds.
Binding that 50 million pounds together is serious work.
There are over 200,000 bolts going in this building. You would never be able to get these bolts tight by hand.
And then you use the impact wrench to tighten everything up. Gun it up, pull it up with the gun and tighten it.
Tightening hundreds of bolts during an 8-hour shift requires a lot of elbow grease.
It's pretty heavy to begin with, and a lot of vibration. Depends on, you got to get yourself in the right position to use the gun. That's a big part of it.
The impact wrench's hidden force? Torque.
You can stumble all over yourself trying to explain what torque is.
What is the tightness of how tight the bolt is? That's the torque.
I'm an iron worker. Talk to an engineer.
It's actually a force that turns something, that will rotate something.
When pushing down on a hand wrench, the downward force is the torque. But a key component of torque is distance, so the longer the handle, the more twisting power.
The impact wrenches that we use on this job site are made to bring the bolts up to 1,500 pounds of torque. To come to 1,500 foot-pounds of torque, a 150-pound man would need a 10-foot long wrench.
But the pneumatic impact wrench dispenses with the need for a long handle and puts the power into the hands of the steel erectors. But they do need air. Like all pneumatic tools, compressed air is pumped in. Inside a pneumatic wrench is a hammer, an anvil, and a bit. The forced air activates the hammer, which causes the anvil to spin, twisting the bit, screwing the bolt into place.
You can tell when the bolt is tight by the sound of the hammer. When it kind of double hits, you'll know the bolt is up to torque.
But before the bolts can be torqued up, the steel girders have to be hoisted into position by what's called the raising gang, 6 ironworkers communicating with the crane operator. Balancing on top of the structure are 2 men called connectors who grab the girders and wrestle them into place. They insert a temporary fastener to hold the new beam in place and move on to the next piece.
The next thing we do is send the bolt eruption as soon as the steel's erected, and they stick all the bolts in.
He sticks the bolt through to me. I put the washer and nut on and tighten it up.
This section of the steel structure presents a problem for Kevin and Tommy. The beams meet at an angle, so they have to pull out what's called the sidewinder.
It's like a 90-degree angle impact gun. It gets in the tight spots like that. So that one's fun to hold on to sometimes.
There are 35 bolts for just this one connection that they're working on right now. But each bolt in a skyscraper has a lot riding on it.
The bolts help spread the weight, the compression, all the way down to the base of the building.
But pneumatic impact wrenches have only been used on skyscrapers since the 1950s. In fact, before then, they didn't even use bolts. Instead, everything from standard 15-story skyscrapers to monumental projects like the Empire State Building used rivets. A method dating back to the 1800s, rivets were ingeniously simple. It's just a short shaft of iron with a head on one end. The heated rivet was slipped through a precast hole in a metal beam and pummeled flat.
The rivet is resting in between the 2 girders, and it keeps them together. They did it on bridges. They did it on steel erection for large skyscrapers at the time.
In the late 1800s, Joseph Boyer took riveting to the next stage with his pneumatic riveting hammer. Inside the metal housing of his invention was a piston. Pressurized air rapidly pushed the piston back and forth, flattening the rivet.
It was such an important tool. It was something that everybody needed. And as soon as Boyer got his invented and got it on the market in October of 1898, it instantly became popular. Once it was on the market, it was being used.
But in the 1950s, rivets ran into an obstacle. Engineers wanted to be able to measure the strength of a single rivet, but that was a problem.
There wasn't any real satisfactory way of determining how much holding power a rivet had. There's no science to it, and you never know for sure if there might be a flaw in the head or in the shank of the rivet. So it was felt to be unreliable.
In 1951, a pivotal report sounded the death knell for the rivet. The Research Council on Riveted and Bolted Structural Joints concluded that bolts had the same holding power as rivets. And since bolts relied on torque to be tightened, engineers finally had a value they could measure. So bolts were poised to take over. In the meantime, a tool had been created which would make tightening bolts a snap. That tool was the impact wrench, developed in 1939 by a tool manufacturing company named Chicago Pneumatic.
And at the time, there was a requirement for a lot more efficiency in the fastening or building of these heavy metal things, tanks and trucks.
But it wasn't until 1957, when it was used in the building of a new Manhattan skyscraper, that the tool would earn its place in building construction.
The Tishman building in New York was one of the first that was used with impact tools to construct the building. And of course what happened, as opposed to using a rivet gun, which you needed a four-man crew, you could start to put these buildings together with two people.
But skyscraper construction keeps evolving, so the tools have to evolve right alongside.
I guess somewhere in the 1980s, it became really widespread in the 1990s. They introduced the TC bolt, tension control bolt.
The novel new bolt has a tip that breaks off automatically when it reaches the right torque. To screw it in, they use the TC gun.
Tension control gun has two sockets, an inner socket and an outer socket. One holds the bolt, one turns the nut. When the nut gets to the proper tension, the tip of the bolt shears off. The tension control gun are all electrically powered, so they are a lot lighter, they're a lot easier to handle.
Kevin and Tommy are working on their 160th and last bolt of the day. And the New York Times building gets closer to its ultimate height.
It gives you a sense of accomplishment when you put the building up, The great thing about the high-rises is that there's always a different view, You come up here.
The largest impact wrench in the world is Ingersoll Rand's 599, named for its weight in pounds. It's so large, it must be lifted by a crane. Modern Marvels will return in a moment. We now return to Super Tools, Skyscrapers, on Modern Marvels.
The next step in building a skyscraper, creating the floors, which means pouring and smoothing a lot of concrete. The concrete used for the floors on the New Palms Tower in Las Vegas is designed to support over 1 million pounds for each of the building's 30 stories.
In our construction of the tower, we have over 30,000 yards of concrete.
Getting all that concrete 30 stories up is the first challenge. And for that, a state-of-the-art concrete pump will do the lion's share of the lifting, or more precisely, pushing.
On the ground, there's a pipe that runs up the building, and the concrete gets pumped from the ground to the pump, and it gets placed by the boom pump.
But even this high-tech boom can't reach every corner of the roof. So they also have to use an older method around here, the bucket brigade. They have 2 buckets on the site that can hold 5 yards of concrete each. As one is being filled on the ground, the other is being lifted to the top by the crane.
As they come up here, the laborers and the guy on the radio there, he swings it to wherever you want
position it, and you just put on that latch. It's got a latch, it opens up openings at the bottom and lets the concrete out.
From the moment the concrete arrives on site, it's a race against time. And temperature to trowel each floor. This process smooths the concrete and squeezes out any moisture so it will set properly.
With the temperatures that we have in Vegas, between the time you place the concrete, you've probably got a 3 to 4 hour window due to the heat.
Bob, 5 machines?
And to get that much concrete smoothed that quickly,
6 machines.
You have to have the power trowel.
More than a tool of choice, the power trowel is a tool of necessity.
No construction company that does concrete could do it.
It's a hand trowel on steroids. The power trowel works sort of like a floor buffer, but this tool has a lever on the handle that allows the operator to adjust the angle of the blades.
The operator has to be trained on the power trowel. It has torque to it, so you have to be used to it to be able to control it. It takes someone with quite a bit of strength to run them.
But even with the use of the power trowel, workers do still need occasionally to get on their knees to use hand trowels.
You still have to do that to get close to bolts and things like that. So you still do have to use hand tools.
Hand trowels have been pretty successful in their own right, a premier tool of the trade since ancient times. In August 2004, a team excavating a 1,500-year-old Roman villa found a trowel embedded in concrete. A simple tool with a flat piece of metal attached to a handle, the trowel would change little over the centuries. Concrete, however, would see lots of improvements. The Romans used a mixture of limestone, animal fat, and blood to make their concrete. A method that would not change until 1824, when British bricklayer Joseph Aspdin invented Portland cement. His breakthrough idea was to fire finely pulverized limestone and clay at high temperatures in kilns.
It was a stronger binder, so they could create a stronger material that had more uses in the building trades.
In 1900, legendary inventor Thomas Edison upped the stakes with his rotary kiln. His twist? Length. 150 feet long to be exact. A longer kiln made better quality concrete faster.
The increased length allowed for a longer duration in the burning zone, which created a higher quality cement.
Edison used his concrete to construct houses, and he laid the first mile of concrete road located near New Village, New Jersey. But all this concrete still had to be laboriously laid by hand, and concrete finishers were getting pretty fed up spending all that time on their knees. In 1939, a concrete finisher in California named Marvin Whiteman was determined to kneel no longer.
And so he scavenged parts from a salvaged washing machine for the motor and then built blades to ride on the concrete, added a handle, and you have your first power trowel.
It was his wife's washing machine, a Kenmore brand from Sears and Roebuck. But Mrs. Whiteman probably didn't mind too much. Whiteman patented his invention and made millions selling it to construction companies.
At first, they were like a crazy wild stallion. You'd say to yourself, oh my God, this thing is going to get away from me. On the original high-rises, they didn't like to use them because whenever you would hit something, it would take off on its own. And they would fly off buildings, yeah? Kind of frightening.
And so they developed a clutch system that allows, with a simple lever on the handle, to start the machine, get control of the handles, depress the clutch, and it would start the rotation of the blades.
With this kill switch, as it's called, the tool can't move unless the operator's hands are engaging the clutch. So no more flying power trowels. The next big advance came in the 1970s, a ride-on power trowel. Available as either gas or diesel powered, these rideable versions have 2 sets of spinning blades, and the blades themselves are longer. They're able to cover 4 to 5 times as much concrete as a walk-behind model.
They weigh 2,200 pounds, so they're not very popular on a very tall building. The trouble is they're heavy, so they're hard to get up there. So, you know, walk-behinds are about all they use.
And that's what they're using back at the Palms Casino in Las Vegas. The walk-behind power trowel. Concrete finishing is done in 2 stages, floating and troweling. Floating starts soon after the wet concrete is poured. This process spreads it out and begins to take off ridges.
When you first start out with the power trowel, the blades are pretty flat. It's for floating the concrete and helping to level it out.
Then it's time for the troweling. As the concrete sets, the operator changes the angle of the blades. As it continues smoothing, the increased angle also densely packs the concrete, forcing out any remaining moisture.
Which is necessary to give it a nice, smooth finish as it gets harder, progressively harder, and harder.
The crew has only one last corner to touch up before finishing the 30th floor, their last for this building.
When we poured this, everything was getting hard on us, so you have to work real fast to try to stay ahead of it. Okay, I gotta go hit this other side real quick, okay?
Today, Ray and his team laid and finished 12,000 square feet of concrete, bringing their total for this skyscraper to 360,000 square feet.
The mightiest power trowel in the world is the HydroDrive 550. It features an 87 horsepower turbocharged diesel engine and bills itself as the most comfortable rider ever. Modern Marvels will return in a moment. We now return to Super Tools, Skyscrapers on Modern Marvels.
At the peak of construction, 600 people work on this new skyscraper for the Palms Casino in Las Vegas. They've got all their specialized tools that help them to build skyscrapers. But there's only one tool that's here from beginning to end. It's the total station, which precisely measures the location of strategic points on the skyscraper.
This instrument is my tool that allows me to ensure that this building is erected straight and plumb and in the right place, and that all the particular items and wall lines and everything else in it are in the right location.
It doesn't look like much, but inside a total station are sophisticated measuring tools that ensure a building is both level and plumb.
Level means parallel to the Earth's surface, plumb means straight up and down. And the walls of a construction of a building need to be level and plumb, essentially so they don't fall over. Otherwise, you wind up with a leaning Tower of Pisa.
3957. Should be 3 off the grid line.
To avoid that fate, the builders of the Palms are relying on Kevin and his total station.
Looks like I got you right about 4 feet. Come this way.
A total station can determine the location of any point by triangulation. To do this, the instrument has a transit, which measures angles. And for distance, it uses a laser-equipped EDM, an electronic distance measuring device.
It's got a laser in there. It shoots out to a prism, which bounces it back. By the length of time it takes, it can determine the distance, and it'll read right down to a millimeter.
The laser measures the distance to the bottom of the building and to a target on the top of the building, forming 2 sides of a triangle. The angle between these 2 sides is calculated with the transit. Using these measurements, the total station determines the precise height of the building, which is the 3rd side of the triangle. With one point on the top floor precisely measured, a grid can be laid out on the skyscraper.
We need to go lay out grid lines up on the top deck so that the carpenters can get out there and they can all start locating all the various features that goes into the building structure itself. And this enables us to do it with a speed that is just amazing compared to what it was, say, 25 years ago.
25 years ago may seem like ancient history to Kevin, but the history of his tool goes much further back than that.
And we know that the Egyptians, who were the first great builders, were the first ones to use different forms of level.
The Egyptians used a plumb line, and if the building was level, the plumb line would hang straight down.
Ever since then, all people who had to construct anything higher than a hut, essentially, needed to make sure that the walls were plumb and level.
In 1666, French nobleman Melchisedec Thévenot changed the leveling world by conceiving a new tool.
He called it an air level, and his notion was really very similar to what we use today as a spirit level. That is, you take a glass tube, you fill it almost completely with a fluid, and he specified using spirits of wine, which is why today we call them spirit levels.
Spirit levels made it onto construction sites in the 1880s when they were mounted in wood frames, making them both cheaper and more durable.
They started experimenting with other types of materials, aluminum in particular, because it was much lighter. And then in the 1930s and 1940s, we start finding plastic levels.
The next advance came in 1951 when the Carl Zeiss Company, a leading manufacturer of state-of-the-art optics, introduced model NI2. It was the first device capable of automatically leveling itself that would be built in large quantities. But without an automated device for measuring distances, steel chains still had to be stretched between the transit and the target location.
I've got 71, and what's your reading? 35.
Which made for some rough going.
In the old days, we'd have had to walk 2 miles from point to point, pulling a chain, hacking brush out of the way. It would take days sometimes to measure distance. When you're using a steel chain, the very temperature of the air will cause the steel to expand and contract. So you've got to make constant corrections for the temperature, for the amount of pull you put on the chain.
EDMs, the electronic distance measuring devices, would do away with the chains. But their development would take decades. A big advance came in 1965 when William Hewlett, co-founder of Hewlett-Packard, was traveling in Afghanistan. He noticed workers trying to set up the bulky EDMs of the day and thought his company could make a better version. His team went to work and in 1970 introduced their first EDM. Dubbed the 3800B, it cut down on the size and complexity of the EDMs and cost a little over $4,000. The following year, the total station was born when the auto level and the EDM were combined. But at a cost of over $12,000, they still wouldn't be commonplace until the 1980s. And then, in the late 1990s, computers were added, compiling all the measurements and doing all the calculations with just the push of a button.
At that point, this just got amazing. And we can go do a layout in the field that in the past would have taken days to get the information worked up. Now we do it in moments.
Kevin and his target man, Ed Keogh, are set up on the newly created 30th floor.
There wasn't even a floor here this morning. They poured concrete, and as you can see, in only a matter of a couple hours, it's set up pretty good. It's hard as a rock.
With the concrete in place, it's time to use the total station to lay out the grid the carpenters need to build the walls.
We brought the instrument up on the top deck, placed it on the tripod over one of the work points we've set from down below. Make sure we're plumb and over the point. At this point, we're good to go and start setting grid up here. Got it, Ed? Okay, let's start doing some grid. Ed, you make that left too, Ed. That's good line. So that's plenty good, Ed. That's a good point. 0.29 away.
When Kevin is done marking his points, the carpenters will move in to begin finishing the floor. And it's an important floor, the last one.
This is the roof deck, so we're not going any higher with it. Oh, this is great. This is when you have a party. A top and off party.
It's a milestone in the schedule that is a big achievement to pour your roof out and top out the building.
The foundation's been dug, the support structure's been put up, and the last of the floors is finally in place. The final step, hanging the curtain wall. 500 tons of shimmering glass specially produced to reduce the Nevada desert glare. And then, Las Vegas will have a brand new landmark, made possible by skilled labor and the super tools of the skyscraper.